in this section we're going to look at section 10.3 ellipses, and ellipses are ovals. And so you'll see here I've got several pieces of information about an ellipse. An ellipse is the set of all points in the plane, the sum of whose distances from two fixed points is constant. Those two fixed points are called the foci. This is a little hard to see. We're going to do something in class on Monday that will let you see, but the foci are going to be these 2 points here on the longest part of the ellipse. So like if you have a horizontal ellipse here, it'll look like this. If you have a vertical ellipse, you'll have these points here. So these points are your foci. And we'll talk a little bit more about why it's important to know what those are on Monday. But for right now, we're just going to be able to identify them and find what they are. The midpoint of the line segment between the foci is the center. This is where you would think it would be. So this point right here, that's the center for both of these. And the ellipse is going to have two lines of symmetry. And so the major axis is the longest line of symmetry. So for example here, this would be your major axis, and in this one would be your major axis. And the shorter axis of symmetry, that is called your minor axis. So, the last one, the places where these axes meet the ellipse are the vertices. So, I'm not going to write here, but there's lots of them. So, these 4 points here are vertices for the ellipse, and these 4 points here are vertices for the other ellipse. So, let's look at the standard form for an ellipse. The standard form for an ellipse, you should notice, is a lot like a circle, because you have x minus h squared and y minus k squared. So that center part is going to work just the exact same way as it did on a circle. The differences in an ellipse and a circle are going to be this. Under each one of your factors here, you've got a letter squared. And the standard form of an ellipse always equals 1. In this case, a is the distance from the center to the vertex in the horizontal direction, and b is the distance from the center to the vertex in the vertical direction. When we graph these, I think you'll see what exactly this means. So for example, I've got x minus 2 squared and y plus 3 squared. So just like with the circle, we're just going to use, for our center, we'll have the opposite of the sign. So we'll have 2, negative 3. So that works just like a circle. So we've got a center at 2, negative 3. But with an ellipse, we don't have a radius. We have a length of our vertical axis and the length of our horizontal axis. So whatever is underneath the x here, we're going to take the square root of that, and we get 5. So that means I'm going to go 5 to the right of the center and 5 to the left of the center. And that's going to give me the vertices on that horizontal axis of symmetry. Then, here I'll take the square root of that 9, which will give me 3. And so, from the center, I'll go up 3 and down 3. So, I'll have vertices here and here. And so, this is going to be my ellipse. And I will draw it in as best I can. These are a little hard to draw, but just make sure it's kind of curved. It looks kind of like an ellipse. So, this would be the ellipse that you would have for this graph. If we go to the next one, this time I would have a center at 0, positive 2. So 0, positive 2 would be right here. And this time I'm going to take the square root of that 4, which will give me 2. So I'll go to the right 2 and to the left 2. And I'll take the square root of that 36, and the square root of 36 is 6. So I'll go up 6 and down 6. And so for this one, we'll get an ellipse that looks like this. And so you should notice whenever you're doing this that if the number underneath the Y is larger, then you're going to have a tall, skinny ellipse. If it's like the last problem where the number underneath the X is larger, you'll have a wide ellipse. So, here we have a picture of an ellipse, and we're asked to write the equation. So we're going to start from the center. So the center here is at 2, 3. So that means we'll have x minus 2 squared, and then we'll have y minus 3 squared. An ellipse is in standard form is always going to equal 1. And then the distance horizontally from the center to the vertex is going to be 1, 2, 3, 4, 5, 6, 7. So underneath our x, we're going to put 7 squared, which is 49. And then vertically, the distance from our center to our vertex is 1, 2, 3, 4. So 4 squared is 16. So we'll put that underneath our y part. And this would be our equation of the ellipse. Here's another one. This time, my center is here at negative 3, 0. So I would have x plus 3 squared plus, I'm just going to have y squared. If you need to put y equals y minus 0, you can, but that just looks worse. And we'll put equals 1. And then horizontally, here my distance is 3. So 3 squared is 9. I'm going to put that underneath the x since it's horizontal. And then vertically, here, my vertical distance is 7. So 7 squared is 49. So I'll put that 49 underneath the y squared. Okay. For this, we're going to have to find the foci of an ellipse. And to find the foci, we're going to use this equation that we have right here. C squared equals a squared minus b squared. And here this c is our focal width. And so here, if I look at this particular instance here, my c squared is going to equal the absolute value of a squared is 25 because the a would be 5. That'd be the distance from the center to the vertex horizontally. So a squared is 25. So we just use the number that is here. And then we would subtract 9. Those absolute value bars are there because we want this to be positive. So if it was 9 minus 25, you'd get a negative, but we're going to take the absolute value. So, but for this one, it's 25 minus 9, which is going to give us 16. And then we'll square root both sides of that. So C would equal 4. All right. So that what that tells me is that on my ellipse, the foci is 4 away from the foci are 4 away from the center. So if I think of picturing this ellipse, you don't have to think so much about exactly where it's at, but we do need to think about whether this is a wide ellipse or a tall ellipse. So this one would be wide because the number underneath your x is larger than the number underneath your y. And the center here is at 2, negative 3. And so for this particular problem, to find the foci, what I'm going to do is I'm going to go 4 to the left and 4 to the right of that center point. So if I were to go 4 to the left here, then that would make this negative 2, negative 3. So one of my answers is negative 2, negative 3. And if I go 4 to the right, then that would be 6, negative 3. So that would be 6, negative 3. And so those 2 points are the foci of my ellipse. Notice that because I was going in a horizontal direction, left and right, because this is a wide ellipse, the foci are always on the major axis or the longest part of the ellipse. I'm adding and subtracting that 4 that I found from the x coordinates. So I subtract 4 here to get -2. I add 4 here to get 6. We'll talk more about why we need to find the foci in class on Monday, but for right now, let's just be able to find it. So for this, I'm finding the center and foci for these ellipses. So for number 1, the center, which hopefully we're good at finding by now, is -4, 10. And to find the foci, I'm going to do c squared equals 121 minus 81. And 121 minus 81 is going to be 40. So my c is the square root of 40. I guess I should have absolute value bars there, but I didn't need them anyway because 40 is positive for this. So in this case, I get c equals the square root of 40. My center is at -4, 10. This is a wide ellipse. And so that center is right there at -4, 10. So what I'll do is I'll go to the left, square root of 40, and to the right, square root of 40. And that will give me my 2 foci. And so since I'm moving to the left and the right, I'm changing the x coordinate. In this case, because we have a square root of 40 and not just a whole number like we had on the last problem, I am going to write my answer like this. I'm going to say -4 plus or minus the square root of 40. And then 10. Like that. So this is really 2 answers. You've got -4 plus the square root of 40, and then a second answer that's -4 minus the square root of 40. But you can write them together here with that plus or minus if you want. Okay. For number 2, I have a center at 2, 0. And this time, I'm going to have c squared equals, the absolute value bars are going to be important here because I've got 36 minus 49. And 36 minus 49 is going to give me -13. And so we need those absolute value bars there because we need that to be +13, and then we'll square root both sides. So we get c is the square root of 13. Now this time, my ellipse is a tall ellipse because if I graph that, I have 49 is larger than 36, so it's going to be taller than it is wide. So my center is here at 2, 0. This time, rather than going left or right to find my foci, I've got to go up or down. So when we go up or down, we change our y coordinate. So our foci would be at 2, and we take that 0, and we would add or subtract the square root of 13. Now, it's unnecessary to write that 0, so probably we would rather see it written like this, 2 plus or minus the square root of 13. And so those are the coordinates of the foci. Okay, the axes are easy but a little bit confusing. So the main thing we've got to remember is x equals a number is a vertical line, and and y equals a number is a horizontal line. Okay, so whenever we have our equation of our ellipse in standard form, then if x equals h is our major axis, x equals is a vertical line. And so since x equals h is a vertical line, that means that the ellipse was taller than it was wide, which means b is greater than a. So x equals h is our major axis. Now this seems a little bit backwards because the bigger number is here, but our answer comes from over here. But when we graph a couple of these, I think you'll see what we're doing. And then, so if a is greater than b, then y equals k for the horizontal line is the major axis. So, here we have one that we're supposed to find the center, the foci, and the equations of the axes for the ellipse. So our center is at 4, -4. And for our c squared, we're going to have the absolute value of 4 minus 144, which is going to be, we'll get -140, but since we have those absolute value bars, it'll be 140. And so c is the square root of 140. We could break that down, but we'll just leave it as it is. So our c is 140. So for our foci, we have to decide whether to add that to the x or to the y. In this case, our number is much larger underneath our y, so we've got a really tall, skinny ellipse here. And we've got a center right here at 4, -4. And so our foci are going to be up and down. So we're going to take 4 and leave it alone. We'll take -4, and we're going to add or subtract the square root of 140 to it to get the foci. We also have to tell the major and the minor axis. So the major axis here, I know that the major axis has to be vertical because this is taller than it is wide. So the vertical line there that goes through the center is your x equals line. So it's x equals, that x coordinate right there is 4. And so then the minor axis is going to be this horizontal line, and a horizontal line is a y equals line, and it's got to have the same y coordinate as the center, so that would be y equals -4. So I like to think about the picture whenever I'm trying to do this. If you look at the equation, it might seem wrong because here you see you got that 144, so it just makes you want to say y equals -4, which is backwards from what you should do. Okay. Here we have to find everything that we had to find the last one, but this one is not in standard form. So much like we had to do with the circles, we're going to have to put this in standard form. And it's going to be a lot like the circles, except for there's going to be one difference. And that difference is going to be because if something is an ellipse, then the coefficients in front of the x squareds and the y squared are different. So since we have a 4 and a 9 here, we cannot divide everything by 4 or everything by 9 in the beginning because it would not get rid of everything. It would, like, if we divide everything by 4, it'd fix our problem with our x's, but it'd make our problem with our y's worse because we'd have 9/4 here. So we're going to have to do this a little bit differently. So we're going to go ahead and split and group our x's and y's together. So we're going to have 4x squared minus 40x plus 9y squared plus 36y. And that will equal, we're going to take this 100 and send it over to the other side, equals -100. And so we can't complete the square when we have this number in front of our x squared. So what we're going to have to do is we're going to have to factor that number out. So we're going to factor out a 4 out of that first set of parentheses. So I'll have x squared minus 10x. And I'm going to go ahead and put a plus blank here because now I'm going to be able to complete the square. And then for the second set of parentheses, I'm going to have to factor out a 9. So I'll have y squared plus 4y. And I'm going to put a plus blank here so that I can complete the square. And so that's going to equal -100 plus blank plus blank. Okay, so at this point we're ready to complete the square like we did with our circles. So we'll have 4 times x squared, I'm sorry, square does not go there. Square goes out here. X minus, because we use the same sign here, and then 10 divided by 2 is 5. Then we have to add, we have to do 5 squared to get a 25. Right here. Here's the catch. Whenever I add a 25 here, I did not really just add a 25 because this 4 is out front, and I would have to distribute that 4 to everything in the parentheses. So when I add a 25 here, it really is multiplied by this 4. So before I add the number to the other side, I have to multiply it by this number out front of the parentheses. So I'm going to have to say 25 times 4, which is 100. is what I'm going to be adding in this blank over here. We didn't have to do that with the circles because we did not have a number outside of our parentheses. In our circles, we could just divide the number off. So we're going to do the same thing over here. We're going to have y plus something squared. This number here in this spot is going to be 4 divided by 2, which gives us 2. And then 2 squared is 4, so we put the 4 in the blank. But be careful, before we add the 4 to the other side, we have to multiply it by this 9 that's out here, because that 9 would be distributed to everything in the parentheses. So 4 times 9 is going to give you 36. So over here on the right-hand side, I've got negative 100 plus 100, which is 0, plus 36. So I get a 36 over here. Now, our problem is that an ellipse has to equal 1. So we're almost there, but not quite, because we need our ellipse to equal 1. So the only way I can get 36 to equal 1 is to divide by 36. I guess I could subtract 35, but that'd make a mess on the other side. So I'm going to divide everything by 36. And so whenever I do that, you'll see here 4 and 36, I could divide both of those by 4, and that would give me 1 and 9. And then over here, I could reduce this, 9 and 36, I could divide both of those by 9, that'd give me 1 and 4. Now, these two numbers right here don't always just switch places, but a lot of times they do. So I'll have x minus 5 squared over 9 plus y plus 2 squared over 4. And that will equal 1. So now I have my ellipse in standard form. Okay. It does ask for the foci, the center, the foci, and the axes for this. So my center is at 5, negative 2. This ellipse is going to be a wide ellipse, and I've got that center there at 5, negative 2. And so I've got to find that c. So c squared is going to be the absolute value of 9 minus 4, which is going to be c squared is 5. So c is the square root of 5. So that means from my center point right here, I'd have to go to the left 5 and to the right 5. So my foci, not 5, square root of 5. So my foci will be at 5 plus or minus the square root of 5, negative 2. All right. Then the last thing I have to tell are my axes. And so this is a wide ellipse, so the horizontal axis is the major axis, so major axis is going to be horizontal. Horizontal lines are y equals a number, and the y coordinate here is negative 2, so this is going to be y equals negative 2. The minor axis is vertical in this case, and vertical lines are x equals a number, and the x coordinate of that center is 5, so it's going to be x equals 5. So here's our equation. We had our center and our foci here, and then our major axis and our minor axis. Okay, here's our next one. We're going to start off by grouping that 25x squared plus 100x together, and then we'll have our 9y squared and our 18y. We'll put those together, and our 116 is already on the other side. So here, I'm going to factor out a 25. I'll have x squared plus 4x plus blank, plus here I'll factor out a 9, so I'll have 9y squared minus 2y plus blank, and that's going to equal 116 plus blank plus blank. So I'm going to complete the square here, so I'll have x squared, square goes on the outside, I keep on putting it in the wrong spot. So I'll divide that 4 by 2, that'll give me 2. I'll square it and get a 4, but and the 25 we bring down here. I think I did that wrong on the last one. No, I kept it. Okay, good. So the 25 we'll bring it on down. When we add to the other side, we don't add 4. We have to do 4 times 25, which is going to give us 100 over here to add to that side. And then for the second part, we're going to have y minus 1 squared. And then 1 squared is 1, so we add the 1 here in this blank. But we do not add 1 over here. We have to do 1 times 9, which is 9. So we add 9 over here on this other side. So when we do 116 plus 100 plus 9, we're going to get 225 here. And so our very last step on this is to divide by 225 so that this equation will equal 1. And so if we divide top and bottom by 25 here, we'll get a 9 on the bottom. If we divide top and bottom by 9 here, we'll get a 25. So we'll have x plus 2 squared over 9 plus y minus 1 squared over 25 will equal 225 over 225, which is 1. So this is our equation. We have to find the center, the foci, and the major and minor axis. So for our center, we will have -2, +1. Our foci, to find our foci, we've got to do c squared equals absolute value of 9 minus 25. And c squared is going to be the absolute value of -16, so that's just 16. So c is going to be 4 when we square root both sides. So in this particular case, our center here, we're looking at an ellipse that is taller than it is wide, like this. And that center is at -2, 1. So for that center, we're going to be adding or subtracting, and for those foci, we're going to be adding or subtracting from the y coordinate. And in this case, because I'm going to have -2 equals 1 plus or minus 4, because I don't have a square root, I want to actually give the coordinates. So I'm going to have -2, and then 1 plus 4 gives me 5. And the other foci will be at -2, 1 minus 4 gives me -3. So those are the foci for this. Lastly, we have to do the major axis and the minor axis. Okay, so our major axis is vertical in this case, and vertical lines are at x equals a number. So the x coordinate here is -2, so x equals -2. And then for the minor axis, that's going to be the horizontal axis there. The minor axis is horizontal, so it's y equals a number, and the y coordinate of your center is 1. So y equals 1. So here is our equation. And here is all the information that goes with that. All right. Okay, here's one more. So we're going to group here. I'm going to shortcut this a little bit. I'm going to go ahead and factor out my 9 as I group them. So I have x squared minus 2x plus blank. And then when I put my y's together, I'm going to factor out a 4. So I'll have y squared plus 4y plus blank. And that equals 11 plus blank plus blank. So here I'll have 9 times x minus 1 squared. 1 squared is 1. Be careful here. We do not add a 1 to the other side. We have to do 1 times 9, which gives us 9. So we add 9 to this side. And then I'm going to have 4 times y plus 2 squared. And then when we square that 2, we get a 4. Add up here in that blank. Don't add the 4 over here. You got to do 4 times 4, which is going to give you 16. So whenever we add those together, we're going to get 36. Last step is to divide by 36. Okay, whenever you do that, you can reduce. You're going to get x minus 1 squared over 4 plus y plus 2 squared over 9 equals 1. So here is your equation for the ellipse in standard form. These two numbers right here, this 9 and this 4, they do not always switch places. In class on Monday, we'll do a couple where they don't, but in a lot of cases, they are just going to switch places. The center of this ellipse is at 1, -2. The foci, so for this one, my c squared is going to equal the absolute value of 4 minus 9, so that's c squared equals absolute value of -5, which is positive 5, and so c is the square root of 5. The number underneath the y is larger here, so we're dealing with an ellipse that is taller than it is wide. Our center is right here at 1, -2, and so we are going to have foci that are above or below that center, so we're changing our y coordinate. So we take the center, 1 does not change, we'll have -2 plus or minus the square root of 5 will give us our foci. Okay, the last thing is our major axis and our minor axis, so major and minor. And so the major axis in this case is vertical because your 9 is larger here. A vertical line is x equals a number, and the x coordinate of that center is 1, so it's going to be x equals 1. The minor axis is horizontal, so it's going to be y equals a number, and the y coordinate of that center is -2, so it's going to be y equals -2. So here are our answers for that question. Okay. The assignment, don't worry about, we are going to work on that on Monday. What I would like for you to do now is to look over the stuff that you may have missed from your test on Friday and see if you can fix it.